Hello friends. Travel time and delay study is a very important survey in traffic engineering, and it is done to determine the quality of traffic flow on a corridor so that you can plan the improvement. It can also be used as a before and after studies. There are several methods of doing travel time and delay studies, but the most important and the most used method is moving observer method or moving vehicle method. And in this method, let us say this is the test section from A to B. So a test car is moved from A to B, and if required from B to A also. 3-4 numerators also sit with the driver in the car. Before this survey is done, a trial run is made, and during this trial run, we identify the points or the location where there are bottlenecks, where delay can occur. Now, the first numerator or the first person sitting with the driver, he will note down the time of arrival of this test vehicle at different points of bottlenecks. The second person will note down the amount of delay caused and what was the reason of delay. For example, if you have, let us say, signal here, then how much time vehicle remained in stop position and the reason for this stop was signal. Similarly, another intersection may be a police control intersection. So he will write the police control intersection, the amount of stop delay is 20 seconds, like that. The third person sitting with the driver will note down the number of vehicles which are passed by the test vehicle, means the number of vehicles overtaken by the test vehicle, and the number of vehicles which overtake the test vehicle. And the last observer will note down the number of vehicles coming from the opposite direction. So you have the number of passing vehicles passed by the test vehicle, number of vehicles which overtake the test vehicle O, and number of vehicles which are coming from the opposite direction NO. These information provide you lot of data about this section. To develop the equations for travel time and delay study by moving observer method, let us consider two ideal cases. Case 1 is, we assume that the test car is stationary and the entire stream is moving. So in a time interval t, let us say time interval t, all vehicles will overtake this test car. And you count the number of vehicles, let us say that is n. And if you divide this by t, that is the flow. That is how you measure flow on a road. You stand on a highway section, count the number of vehicles in time t. So rather than standing on the road, you are sitting in the car now. Car is stationary. You are just counting all vehicles which overtake this car. So that is Q is equal to N naught upon T, or N0 is equal to Q into T. The second case is when, let me put equation 1 here. The second case is, you assume that the car is moving and the entire traffic stream is stationary. So this car will overtake all the vehicles now. Let us say this is the length of the section, and let us say number of vehicles which are passed by this car, test car, is NP. So NP upon L, that is how you define the density. So this is K, or NP is K into L. Now if you assume that the speed of this vehicle, moving vehicle, is V and it take time T to traverse this distance L, then this L will be equal to K into V into T. So this is the second equation. NP, number of vehicles passed by the test car. So this is equation number 2. Right. So These are two cases, very ideal case. But in actual case, both are moving. Test car is also moving and the stream is also moving. So in that case, there will be some vehicles which will be overtaken by the test car. This will be passed by the test car, and there will be vehicles which will overtake the test car. And the number will depend upon the speed of the test car with respect to the traffic stream speed. If the test car is moving at faster speed, it will overtake more number of vehicles. If it is moving at slower than the average speed of the stream, it will be overtaken by more number of vehicles. So when the test car is also moving and the stream is also moving, then let us say this n naught minus np is equal to m. Difference between overtaken and overtaking vehicles. So this m is n naught minus np, and this will be equal to qt minus kvt, or m upon t is equal to q minus kv. Now this is the fundamental equation of moving car method or moving observer method, which relates fundamental parameter q and k with speed, time and m. Remember, n is the difference of number of vehicles overtaken and passed. Now, from a test run, you can find out what the value of m. You can count the number of vehicles, how much time it takes to complete the test run, and what was the speed of the movement. These three parameters you can find out. These three parameters you can get from a test run. Q and K are to be estimated, and therefore you need two equations to solve this for Q and K. And therefore what is done, that we make two runs, either in the same direction or in the one in the against the traffic, another with the traffic. So you can run the test vehicle from east to west and then from west to east to get all these data. So you have now two equations. You can solve these two equations to get Q and V. Remember, till now we have not assumed any traffic from opposite direction. These two cases we took when there was no traffic from opposite direction. So if you are making one test run, let us say with traffic, and another test run against traffic. So if I write these two equations, that mw upon tw is q minus k into vw. And when you are moving against the traffic, then in that case speed will be negative, and therefore this equation will be ma upon ta is equal to q plus k into va. You can rewrite this equation. mw is equal to q into tw minus k into vw into tw, that is the length of the section, kl. And similarly you can write this equation qta plus k into l. These two equations will give you the ma upon mw, ma plus mw upon 2a plus tw is equal to q. That is how you can find out the flow. And if you know flow, now you can use this equation again to get the stream speed. Vmw upon tw is equal to q minus k into vw, or this can be q minus k is again q upon vs into vw. This is equal to q into 1 minus 1 upon vs into vw. Now this vw you can write L upon tw, and this L upon Vs will be equal to T bar, average time of the stream, because this Vs is the stream speed, because you find out, you substituted K by Q upon Vs, that is fundamental equation. So this will be equal to Q into 1 minus T bar upon TW. If you simplify this, it will be that TW minus MW upon Q. Now, this is the equation which will give you average time. This is less than the time taken by the test car. This is the time taken by test car. This is the average stream speed time taken by the stream. If the test car moves at a speed which is equal to the stream speed, then this T bar will be equal to TW. Similarly, you can find out in the opposite direction also. In TA bar will be equal to TA minus MA upon Q. Q is from this equation. Now, once you know average time, you know the length of the section, you can find out what would be the stream speed. Space means speed of the stream. So, you can find out all three parameters of traffic flow, Q, K, V. Now, this is very important to know the travel time or quality of flow on a corridor, and you can plan the improvement. And after improvement, you can again do this exercise, this survey, to find out how much travel time has increased or reduced by implementation of traffic management measure. Now, these equations have been derived, again, assuming that there is no flow from opposite direction. That means the street is one way. If the street is two-way, then in that case, in case of two-way movement, this equation gets modified, that Q is equal to, and I'm just putting here east-west, so QE in each direction will be NW plus OE minus PE upon TW plus TE. And similarly, in the west direction, the flow will be NE plus OW minus PW upon TW plus TE. Time taken by the test car while moving westward and eastward. This is NW. That is the number of vehicles opposite direction, coming from the opposite direction. This is overtaking, this is passing. Now, this is the vehicle which your test vehicle will pass. And these are the vehicles, number of vehicles which will be passing or overtaking the test vehicle. So, you can find out flow in two directions. And similarly, the equation for T will change to TE minus OE PE upon QE, and TW will be TW minus Q in west direction. Again, I will repeat that this is the time taken by the test vehicle. So, if you have, let us say, you have made 5 runs. So, this is the average of 5 runs. But it doesn't give you stream speed. For stream speed, you have to find out the average time. Now, let me just take one example to illustrate this procedure. And example is that the length of the corridor is 1.2 kilometer. And it is traversed at average speed of 25 km per hour. 25 km per hour. So, how much is the time taken by the test vehicle to traverse a distance of 1.2 km at a speed of 25? That will be 0.048 hours. This is in one direction. During this test run, 100 vehicles were from opposite direction and 14 vehicles overtook the test vehicle and 70 vehicles were overtaken by the test vehicle. So this is P, this is O, this is N. Opposite direction. Now you have the test run is made only in one direction. So let us assume that the flow in two directions is similar, and therefore T1 and T2 will be the same. So the Q will be N plus O minus P upon TE plus T west. So this is 100 plus 14 minus 17 divided by 0.048 plus 0.048. And this is equal to 458 vehicles per hour. That is the flow. This is the flow. And you can find out what is the stream speed or the time. TE bar is equal to 0.048 minus O 14 minus 70 divided by Q. Q is now 458. So this is 0.170. You know the test length 1.2 kilometer. You can find out what is the speed. So stream speed will be 1.2 kilometer divided by 0.170, that is 7 kilometer per hour. You know flow, you know stream speed now, you can find out the density. K, 458 divided by 7, around 65. 65 vehicles per kilometer is the density. Now this information you can get by collecting several set of data. Let us say you take a data on a corridor at 8 to 9, 9 to 10, 10 to 11, 11 to 12. And you get different because the flow will be different at different times. So 8 to 9, let us say this data, that the number of vehicle coming from opposite direction is 100 and O is 14, E is 70. 9 to 10, this data may change, and let us say this is 113, 25, 41, 30, 15, 5, 79, 18, 9. These data are collected by making 4 runs. Now you can see here, the flow here is very heavy because you have 113 vehicles. Here it is very light traffic, only 30. You can change the speed of the test run also. Here we assumed a speed of 20 km per hour. Speed of test vehicle 20, and let us say this is 18, 30 and 27. For each set of data, you can find out Q, K, V. So this Q is 458, this stream speed is 7, this is 65. Similarly, in the same manner, if you analyze this data, you get another set of Q. Q is now 727, one speed is 13.5 and this is 53.7. Similarly, in the next, you have some 500. Now, this data you can use to make a plot between speed and density. And that plot you can use to, this is the plot, to fit a line, Green-Still equation between speed and density, optimize it, find out the capacity. So how capacity is improving after taking certain measures of traffic management, that can also be estimated from that. That is moving observer method. Very powerful and most used method. Thank you very much for watching this video. You can write your suggestions in the comment box.